Hi, and welcome to question 9 of the Leaving Cert Maths Ordinary Level 2020 Paper 1. If you want to copy these notes, just send me an email at shanetroy@gmail.com and click subscribe to see other playlists.
Game. Sure enough.
Okay, so on question 9, okay, now it's a sequence and series question. So it's worth 60 marks, so there's a lot to it. Now, even just looking at it without doing anything to do the questions, first pattern has, now it's got 3 matchsticks, okay, it's forming an equilateral triangle. So all 3 angles are equal, although I don't think I need that, which means all 3 sides are equal length. Okay, that's just what an equilateral triangle is. Okay, there's also one triangle. So if they're making pattern 2, there has now 1, 2, 3, 4, 5, 6, 7 matchsticks, 3 triangles. Pattern 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now I could keep going if I imagine it. Okay, but if I think this pattern is linear. Okay, so it's going up by a consistent amount each time. If I take 7, take away 3, I get 4. Now if I take away 11, take away 7, I get 4. So all I got to do with the next one is add 4 each time. So 11 and 4 is what? 15. 15 and 4 is 19, and 19 and 4 is 23. Okay, so you could have just kind of drawn them. Now you don't have much space to draw them, or visualize them in your head. But this is giving you a pattern to follow. The pattern just happens to be linear, although you're not really being asked that. Now, part B, part 1 there says, how many matchsticks are required to make pattern 10 of the sequence? Now, this is where you could just add up, okay? And if this pattern 6, you could just go up like 27, 31, 35, 39. So I think my answer here is going to be 39, okay? Or I could use this formula, okay? Now, it's the total number of matchsticks is equal to, what's the answer? I have it done out. It's the formula there in the match tables in the section on sequences and series. Okay, so that's your total number of whatever in the pattern. That's your first value. That's your number of pattern. Okay, and that's the difference. So we know the difference is 4. We know the first value was 3. Okay, so that's 3. Now this n, now if it's the 10th pattern, which we're being told in the question it is, your n is equal to 10. So I have those 3 things kind of called out there. The equation has 4 things. I know 3 of the 4 things. I can find the other thing. It's worth pointing out with this kind of notation, the 10 there just represents which pattern it is or which thing it is. Okay, it's here is where it matters. So 3 plus 10, 3 plus, and then 10 to the minus 1 times 4. Okay, and 10 to the minus 1 is in brackets. So that's the same thing there as 9. I put through the calculator. Okay, it should program, and I got 39, which is what I predicted. Just kind of thinking it or working it up. No right or wrong. This method, if you do get it wrong, because you calculated it wrong, you're going to still get marks. If you just guess it by counting up in your head and don't write anything down, and you get it wrong, it's 0 marks. So there's different strategies. Now the last thing here says, find a formula for T of n, the number of matchsticks required to make pattern n of the sequence. They're kind of saying, look, don't put a number in. Okay, just work in general. So if I get away some of the fluff there, okay, this again is our formula. So they're saying, what's this, okay, when this is just any pattern? So leave n as it is, and you're looking for this. So there's going to be 2 unknowns, but your a is still 3, your d is still 4. So I put that in there, and then just remove the brackets. Okay, so it's 3 plus, now the 4 multiplies by both terms. 4 by n is 4n, 4 by minus 4, 4 by minus 1 is minus 4. Now, that's it. All I'll do is tidy it up. The minus 4 and the 3 can combine together to give minus 1. So this is my formula. If I know n, if I test it, what was t of 10? Okay, is equal to 4 times 10, take away 1. 4 times 10 is 40, take 1 is 39. So it agrees with what we got in part 1, because it's right. Now the next there for part B, part 3, okay, it says pattern K has 140 7 matchsticks. Now it says k is an element of n. It doesn't mean much, just means k is going to be a positive number. Find k. So now we know that t of n is equal to 4n minus 1. Okay. Now we don't know what n is, but we know that it is t of n is 147. So once you make that realization and put it in, this is an equation of one unknown. Okay, bring the minus 1 across, you end up with 146 is equal to 4n. Bring the 4 across, so it becomes divided on the left. Put it to the calculator, now I have it done. And I go, what, 37. So the 37th pattern will have 147 matchsticks. Now, if you went in your head and counted up, pattern 11 will have this, and iterated it up and up and up, you could have found the answer. Okay, just would have taken a long time, and potentially you'd have made a mistake in your arithmetic in the calculation in your head. Now, part 1 here, I might as well leave it here. It says find a formula S of n. Now, if you look up in the maths tables under sequences and series, you'll see formulas for arithmetic sequences and geometric sequences. Now, the arithmetic sequences are ones that go up by a constant amount. Okay, that's the ones that I think are on the Leaving Cert Pass Math syllabus. This is the sum of all your patterns formula. Okay, now if I write down, I know what A is, so I know that was 3. I know D is 4. That hasn't changed. I'm looking for a formula that tells me, if I know which pattern, how many matchsticks will be in that pattern. So like part 2, I think, just put the numbers in, okay, and then use your algebra to resolve it. So 2 times 3 is 6. So moving over here, 2 times 3 is 6. That calculation is done there. And then 4 times n is 4n. 4 times minus 1 is minus 4. Now I can multiply that in. Actually, these things can add together. 6 times 6 minus 4 gives me plus 2. And I probably could have gone one step further and gone n over 2 by 2 would be the same thing as 2n over 2. Plus, now n by 4n would be 4n squared over 2. I could have then simplified that further. 2's would cancel. You're left with n plus 2 into 4 goes twice. And I'm not sure if that's simpler form. Would that be a better answer? I'll have to look at the mark and see, but look, maybe I should look at the mark and see just while I'm doing it. Okay, and question 9, C part 1. Okay, formula with some substitution. They don't say if that's acceptable on the actual marking scheme. It might be. It just would have to be interpreted as part of the marking conference. Look, I should have finished it off just to be sure. Anyway, I didn't. So now I'm using the formula identified in part C part 1. So that's whatever I got in part C part 1. Even if I didn't know what to do, I just made up an answer. It's accepted in part C part 2. I know that the total number of matchsticks, okay, in S of n, I'm told is 820. So I can put 820 equal to my formula. Now, hopefully you get that, because if these two things are equal, well, then these two things must be equal. Once I've made that connection, I can solve it. Okay, now I've now went on that further step of multiplying the n over 2 inside the bracket, and I've done that up here. But I end up with this quadratic. Now, if I bring it all to one side, and I've done it there, I end up with quadratic. Now, I could use the minus b formula. Okay, what I've done here is I've used the quick method, and I went open up 2 brackets. Let me go back a page. 2n squared plus n minus 120. 2n squared minus n is a minus plus n minus 820. Now, because there's a number in front of the n squared, this always puts me off. But the way I would have learned in school, and you might have your own method, there's no right or wrong here. You put 2n into both brackets. So, then you multiply this 2 by the last number here, which is minus 1640. So I'm looking for what 2 numbers multiply to give negative 1640, but add to give this number here, which is plus 1. Now, you could tap away with your calculator. Okay, I have it here. So it's 41. So let's try the calculator. I have a hint there of what it is. So 41 times 40. Okay, that's right. Now I want my number, when I take them away, I want my number to be positive. So it'd be plus 41 minus 40. Sorry, why it does that? It doesn't recognize the pen. Minus 40. I could leave it like that, but the last little bit is I have to have the one that's halvable, which I don't think is a very acceptable way of saying it. But there probably is a better way. And n minus 20, which I should have here. Okay, and then I can put both of them equal to 0 now. Very tight on space in a sense, but I'm putting both equal to 0 and then solving them. Okay, and I get my two values of n. It can't be negative, so n is equal to 20 is the answer. Okay. Now the last part here, and I know we've gone fairly long, D part 1. So this is kind of looking at the scenario from a different perspective. They're saying instead of the number of matchsticks, which is what the first part A and B and C we're looking at, part D here they're saying how many triangles are there made. So in pattern 1 there's one triangle, that's represented here. In the second one there's 3 triangles. Now in the pattern 3 there's 1, 2, 3, 4, 5. Now if you see the pattern, going up by 2, going up by 2. So what's the next one here going to be? 7 goes up by 2, 9 goes up by 2, 11. That's it. Now it says, actually I would show a calculation. If I said 3 take away 1 equals 2, just it should show a calculation. Now, if you got the wrong answer there and went up systematically in the wrong way, you still get the right most of the marks, basically. Now, part 2 here says the area of each triangle is 4 times square root of 3 centimeters squared. So it's an awkward number, but it's just a number. It says find correct to the nearest centimeter squared, so that might be important, but we'll see. The combined total area covered by the first 15 patterns in the sequence. Now, look, if you know your formulas for area is equal to a half base by height. That might be useful. Okay, maybe not, but we'll see. And if I then go find, so the total area of the first 15 patterns in the sequence. So I need to find the total number of triangles, which is the sum of. Okay, so I probably have the next page. Let's flick to the next page. That's the formula. I know the A in this case is 1. The D is 2. That's the pattern. N is 15. Okay, and that's 15. I'm looking for this. So I put all those different numbers in. Okay, put to the calculator. It gives me a number of 225. And the calculator can do all of this. Now we know the area is 4 times square root of 3. So I'll multiply that by the 225 triangles. And that gives me this area. And they said to the nearest centimeter squared. Okay, so this is one decimal place. Because it's over 5, it makes the next number round up. And we have an answer of 1559. And that's it. Okay, so I think that's the end of question 9. So it's a tough question. Sequences and series can be grand if you get the hang of them. But if you're seeing them without practice, they can be very, very tricky. But the formulas are there in the math tables. It's just remembering that fact. So that's question 9 of paper 1 of the 2020 Leaving Cert Ordinary Level paper. If you want a copy of these notes, just send me an email at shanetroy@gmail.com. If you click subscribe, you'll see links to other playlists for other years. Okay, so thanks very much.